Okay, today I'm going to talk about the savings calculation feature and just explain a little bit how it works. This is a new feature where it's supposed to figure out how much money you might be saving, both with your home battery and solar system and by using Predbat on top of that. So there's a chart here that you can add in. The template for this chart is in the usual GitHub area under templates. So if I just look at the code for this chart very briefly, you can obviously cut and paste it from there. It's showing three things here. It's showing the actual cost yesterday that was calculated based on your imports and exports. So it might not be perfectly accurate. It depends on how your inverter tracks those versus your smart meter. Then we've got the savings yesterday with Predbat and the savings for your entire PV battery system. And those are the three columns here, and I'm showing it each day. So these only change once a day, essentially. So they're showing the current entity is the previous day's figure, and then it rolls over each day. So this chart is actually showing groups of 24-hour periods in columns over the last 7 days. So if you have a look at my data here, what you'll see is three figures. So the actual cost is how much it was predicted to appear on my bill. This includes standing charge if you've enabled it. Then we have two columns for the savings, and I actually had a bug in the previous release where the standing charge was not included in the calculation for the savings, and so they were rather pessimistic. Now this is fixed in the latest release, so you may want to update. So I'll just show the release here just so you can see which one it is. This is pretty new. It's 7.19.2. Okay, so then savings PV battery is pretty simple to explain. What happens is that it runs a Predbat simulation of your system with no battery and no solar, and then works out the cost. So essentially it's just your load times the import rates at the particular time, and obviously your what you might have exported times the export rates. But obviously, you can't export when there's no PV, so that's always going to be zero. Silly comment there. So that's just going to give you your cost, and here it's saying £5.18 yesterday, and is the savings that I made. So the actual cost was minus 45p. It would have cost me about £4.50 or something. I didn't do the maths in my head. And then the last one is savings with Predbat. So what this is saying here is that if you didn't use Predbat and you just had a very simple strategy where you set your battery to charge on the cheapest rate to 100% every night, how much more would it have cost? And so that was 71p extra there that we saved. So the actual cost, it would have been about the £1.20. You can actually change this chart if you wanted to show the predicted amounts rather than the savings. There is some attributes on these sensors. So if I look at those, so you can customize this. So if I look at the savings Predbat here, you can see the actual cost is that red one here. The predicted cost would be how much it would cost essentially without Predbat. So you could show the actual values if you want. SOC yesterday and final SOC, so that was the battery level at the start of the day and the battery level at the end of the day. They just happen to be the same because of the way that my battery is charging, but they won't always be the case. And then if you look at savings PV battery in here as well, you will see just the predicted cost there. If you didn't have PV in battery, it would be £4.72, and the actual cost was minus 45p. And so you're going to get these over time. The other thing you can do is chart your total savings. Now, just to slightly confuse things, I've just changed this to pounds rather than pence. So what you see in the current sensors, it's just changed to pounds. So this is going to reset again. But hopefully that will be more readable this time, but yeah, you might lose some history on there, and so you can chart your PV battery savings and your Predbat savings in total. So hopefully that's a useful feature. I just want to keep in mind it's completely approximate, so it might not really be the case, and also in some cases that will cost you money rather than save you money, because if you set up, say, PV 10% scenarios and it turns out to be sunny and you've charged more than you need to be, or maybe you've enabled some other carbon optimizations, or maybe you've changed metric battery cycle and tried to reduce your battery use, then it won't necessarily always be the cheapest, but hopefully over time you can see the savings knock up. Okay, well, thanks very much, and hopefully that's useful.